All right, guys, here we are with our first ever Mr. Thompson instructional video. How about that? Okay, so we're going over the SAGE reviews, which is really the Aspire reviews, and I'm gonna try to get through this whole packet. There's 3 pages here. We're gonna skip a few of them because they're not all incredibly relevant and some of them are a little out of order, which is fine. We're gonna get to everything eventually, but what we're gonna be doing in this video is we're gonna cover, we'll start by doing this front page, 1C, which is what I've got on the board there. I've got 1C, 1A, and 1B. All of those are up on the board there, okay? And so we'll get through those and then I'll erase what's up there, and then we're gonna go through, right here, we'll go through 2A, 1C, and then we're gonna skip the 3B problem because we'll have that in another video, and then we'll move on to Unit 2, which is 2B, or not 2B, that is the question. 2C, right here, that's another one we're gonna skip actually. We're gonna skip 2C and then we'll go back to 2A at the end. So I'm hoping this video doesn't take more than like 15 or 20 minutes, and I'm also gonna try to like timestamp it. Again, you guys, I'm not very technologically savvy, so I'm gonna try to just get better at this stuff as we go. But here we are. You know, we're gonna maybe stumble through some things here and there, just like it is in real life and in class occasionally. So we'll start right here with 1C. Okay, so what we need to do here is we know that these are proportional triangles. So we're gonna use that concept to find x. Okay, so x is the part of the triangle that's MT, the line segment M to T. Okay, and so if we know that triangle UTV, right here, UTV, is similar to triangle MTN, then we can figure this out. And so the trick we learned here, you guys, missing a marker, we'll go with that one. Okay, so the trick we learned here for doing this back in the day was we just kind of labeled these. We had our underline like this, we had our bracket, and then we had our little arc, okay? So what we're gonna do here is we're gonna label these in that exact same way. So I'm gonna go, the first 2, those get underlines. And now once I've done it here, I'm also gonna find where they are here, and I'm gonna do it here as well. Okay, so UT, that's right here, 35. MT, that's right here, that's our X. That's what we're gonna solve for. The missing side length, okay? And we did bracket, and you know what, we'll keep it as pink, that's fine. So bracket is gonna be the last 2, okay? TV, I know you guys have been watching a lot of TV, and TN, okay? So TV and TN, TV is right here, that gets the bracket, and then TN, that's right here, that also gets the bracket, okay? So now we have everything we need to actually solve for the variable x. This is actually gonna work out pretty well. Okay, so basically what we're trying to do here is identify which ones are similar, okay? So I can do, this is similar to that, so I can either put them equal to each other or I can put them on top of each other. It's gonna work out either way, really. So what we're gonna do here is we're gonna put them on top of each other. So I'm gonna say MT, which is x, but I'll do it all, we'll go MT like this, divided by UT, okay, this ratio needs to be equal to, so we did MT on the top here, so we're gonna have to put TN on the top here. TN divided by TV, okay, and we'll make this more of a U so that it doesn't get confusing, TV, okay? And now we're just gonna plug in the variables and the numbers that we have, and eventually we're gonna have an equation where we can solve for x, okay? So MT is our x, that's right here. So I'm gonna go x divided by, UT is 35, and we're gonna say that that equals TN, which is 16, divided by TV, which is 56, okay? And so now I'm hoping we're all like pretty good on our algebra rules and we can easily figure out how to solve this. The trick to getting x by itself here is that I have x divided by something, and the inverse of dividing is multiplying. So we'll multiply both sides by that something, which in this case is 35. Okay, so we'll multiply both sides by 35, multiply by 35, and I get x equals, and in my calculator real quick, I'm gonna do 16 divided by 56 times 35, okay? And I will, let me find my calculator. I can't find one. One sec, I'm gonna grab one from over here. All right. So I'm gonna go 16 divided by 56 times 35. Okay, so this is what I've got in my calculator. Boom, 16 divided by 56 times 35. I press enter and I get 10. Awesome. It's gonna work out for us. So what we end up with here, once everything is kind of canceled out, like this, x equals 10. And this is our answer. Cool? Any questions, guys? Ha, you're not here. Okay, now let's move on to 1a. So what we're talking about with 1a is, and this is one of the concepts that I'm okay answering this question, but I'm really not gonna like belabor the point here just because this is the kind of thing where everything is just like definitions. Like the notes that we have here for this, I've got like, so this was when our notes were in green, but yeah, we've just got like all these definitions that we kind of talked about. And so when things are just definitions, I don't really love having to go over them over and over again. But we will go through this one just briefly. So this one's asking about alternate interior angles that are congruent. So two things we need to kind of think about here is alternate interior. So if we're talking about interior, let's remember that these lines are going to be our parallel lines. Okay, so our interior is going to be here. We have interior here, here, and then this is also kind of an interior in a way, but we're not going to worry about that too much here. And then congruent is the other thing we need to remember. Congruent means that they are going to be equal, okay? So our alternate interior angles that are equal, well, the first one that I see here is 6 and 12, okay? So I'll circle these. How about we circle them in pink? I really need to get another blue marker. Okay, so 6 and 12, right here, 6 and 12. We can see that those are, you know, this line crosses, so our alternate interior, we're kind of just going across this line right here. So our first pair of alternate interior angles are 6 and 12. Okay, then our second pair, well, if it's 6 and 12, then the next obvious one is going to be 7 and 13. Okay, 7 and 13, and I'm just occasionally looking down here to double check and make sure I've got the right answer. 7 and 13 are here and here, 7 and 13. And there's going to be two more. Some of you, I hope, have already figured out which ones they are. 7 and 13, 6 and 12. If we follow kind of that same pattern that we did up there, we should see that down here we've got 8 and 10. Those are going to be alternate interiors. And brown marker is done. And I don't have any other color markers, so we're just going to have to keep going like this. Okay, so 8 and 10. 8 and 10. And then the last one is going to be 9 and 11. Okay, so 9 and 11. And these are all of our pairs of, I'll even write it one more time. These are our alternate, and that's gonna look like crap. Let's go alternate interior angles. Okay, so I hope we feel okay about that. And again, this is one of those things where if you don't get it, don't be too like worried. Just because this isn't the kind of thing that's going to come back, I don't think in like a huge way in secondary three. Like some of the small concepts might, but a lot of the other stuff we go over is going to be more important. Okay. And another thing with these videos, you guys, is as I'm just sitting here kind of talking, they might end up being longer than I hope. I hope they're like 20 minutes. They might end up being a little longer. If you want to take a break, just pause it. Don't you wish you could just do that in class? You could just pause Mr. Thompson and then just like replay him again later on in class after you've taken your nap or whatever. Jack, I'm talking to you. Anyway, we'll move on here. Okay, so 1B, this is talking about similarity rules. So we want to know which similarity rule applies, and there really isn't a lot of math we need to do here. I will label these real quick. So we have A, B, E, C, and D. Okay. So these ones, yeah, we kind of had to do a little bit. This one we had to do a little bit of math. This was sort of just remembering things. And this is kind of more of like this one where we're just sort of remembering. The main similarity rules we have are side, 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 SSS. So that would be if we were given side lengths for each of these, okay? We don't have any side lengths, so we already know we cannot use that one. Side angle side. Again, that would be if we had a side, an angle measurement, and a side. Well, we don't have side lengths, so that one's out of the picture. we have angle, angle. This one is we're probably going to be able to use this one. We actually are definitely going to be able to use this one. I'll explain why in a second. Or another answer would be if we have like none of them. Oh, there's an announcement. Not for me. Okay. That's kind of funny. Announcements in the middle of videos, you know, just like we have announcements in the middle of class that are annoying. Okay, so it's not going to be none. It's going to be this one, and I'm going to explain why. Angle, angle. So this goes kind of back to alternate interior angles, you guys. And there's one other concept that is applicable here, and that's vertical angles. So one angle that we know is going to be equal, or one set of angles here, is going to be right here. We've got our vertical angle pair right here. And that's just because the way they're crossing, this is something that we went over a lot. It's in the notes. If you need a refresher, you know, type something down in the comments and we'll go from there. And then the other concept that is going to be relevant here is, yeah, our alternate interior angles idea that we did over here. And the idea is that if these lines are parallel, which they are because of this little thing right here, okay, that means that we're going to have kind of the same pattern, okay? So like 6 and 12, that pattern that we see there sort of exists right here with A and D, and also with B and C. Okay, so our angle measures that are equal are this angle here, and then these angles, these are equal, and then these angles are equal. So this is how we know that the theorem we're going to use is angle, angle, okay? All right, so we're through the first page now. I'm going to flip over to the second page. If you need a break, you need to go grab a snack or something, you're texting back one of your friends, now's the time to do it. We're going to move on, and now we're going to get to the second page here. So I'm going to erase what's on the board, and we're going to do 2A up top here, and then we're going to do 1C, just this one on the left. And then we're going to skip 3B, and we're going to do 2B at the very end, okay? Well, I guess not the end, because there's a backside as well. But we should be through this pretty quick. We're 12 minutes in, so we're doing all right. We're hopefully going to stick to the 20-minute mark that I was aiming for at the beginning. I can erase all this now. This is just like, you know, back if we were actually in class. I could just look over and someone's walking in late. And I'm like, hey, grab a calculator, grab some notes, all that kind of stuff. You know, I'm just trying to make it fun, you guys. I'm going to be sitting here by myself doing videos, and it's going to get real old without anybody here to interact with. So I'm just going to be talking to myself, rambling a little bit. All right, so 2A. So I actually should have kept part of that still up. This is still Sage Review number 1. Sage Review number 1. But now we are on 2A here, okay? So 2A is at the top. And what 2A is asking, this is the very top right here on the second page of Sage Review number 1. This is asking for us to draw a picture of the midsegment theorem. Specifically the triangle midsegment theorem, which says that if a segment connects to the midpoint of two sides of a triangle, then the segment is parallel to the third segment of the triangle, okay? And this one is pretty straightforward. Basically what we're doing is we're just going to draw one big triangle like this, and then we're going to draw a midsegment just like this, okay? So we know that this is going to be equal to this, because if it's the midsegment, then what that means is that it's literally cutting this whole entire line in half, okay? So it's cutting this whole line in half, and if it does that, then that means that this line from here to here, so let's give this some labels. Let's say A, B, C, D, and E. So basically what we're saying is that the line AB is equal to the line BC, okay? Same thing over here. The line AE is equal to the line AD. Very straightforward. And the main thing to remember here is that this midsegment right here, let's just call this X. This is going to be exactly equal to essentially 1/2 this. So this one underneath is going to be 2 times X. This is going to be 2 times bigger than this line here, okay? I hope that makes sense. And that's really it for that question. So, and again, you guys, as we're going through this, I'm doing the ones on the left. I want you guys to do the ones on the right on your own. Take a picture, scan it in, do whatever you got to do to get it to me. That way you can get credit going forward, okay? So that was 2A. This one's pretty easy. Let's see, 1C. And I know that all of this stuff has been uploaded. So it's in that modules section, so you can double check there, and you're going to see all the answers on the left. This is just me kind of going through it to give you an explanation. Okay, so a tree has a 30-meter shadow. So now I'm going to be onto this 1C right here. Again, I'll give you guys a little close up. We're on 1C right here, okay? So a tree has a 30-meter shadow. That's where this right here comes in, 30 meters. A man that is 2 meters tall has a shadow of 3 meters, okay? So the man is 2 meters tall. He's right here. This is 2 meters. And this is like not to scale at all, obviously, okay? And his shadow is 3 meters, okay? So we've got this triangle here. And without even really reading this as a story problem, all we're doing is we're trying to solve for x here, the height of the tree, okay? And we're going back to the concepts we did on the front page, which is triangle similarity. So we have these are similar triangles because this angle is going to be equal for both of them, okay? And then, so this is basically, this would be side angle, yeah, this would be a side angle side theorem, okay? Because we have sides, we have angle, and then we have sides. So side angle side is kind of what we're using here. So the idea with what we need to do is we're just going to kind of use the proportionality idea here. So I'm going to go, this triangle, basically, all the proportions are equal. So I'm going to go 2 divided by 3. So I take this side divided by this side equals x divided by 30. X divided by 30. And you can set this up different ways. Like if I wanted to, I could have gone, and I'll actually show you guys that. Let's do it this way and then we'll set it up a different way just so you can see that it can be done more than one way. So if I want x by itself here, I'm just going to multiply both sides by 30. So I multiply by 30 here, it cancels, I multiply by 30 here. And again, I could use my calculator if I wanted to, or we can just try to do this one in our heads. 30 times 2 is going to be 60. 60 divided by 3 is going to be 20. So I'm going to have an answer of 20 equals x. Okay, so that's one of our answers. That is our only answer. So now if I were to set it up a different way, like I just told you guys, let's say I decided I was going to go 3 divided by 30. Let's actually flip it though. Let's go 30 divided by 3. Let's say 30 divided by 3 equals, so we did big segment divided by small segment. So we're going to do big segment divided by small segment. X divided by 2. Okay, so again, what we're going to do here is we're going to multiply both sides by 2. We want x by itself, so I'm going to multiply by 2 on both sides. Multiply by 2, cancels here, and again, I'm doing 30 times 2. You can use your calculator if you want. 30 times 2 is 60. 60 divided by 3 is 20. It works either way, you guys. Okay, so we end up still with this answer of x equals 20. So that's a good one. This kind of stuff is pretty applicable. You're going to see this kind of stuff later on in your math classes, so that's good. Good that we have a chance to kind of cover it again. Okay, so 3b is the one we're skipping, and we're going to go down to 2b here. And I've got a little room, so we'll rotate our camera a little bit. Oh, we're good. We don't even really need to rotate. Okay, so I'm going to do 2b here at the bottom, and we're going to try to power through here. I'm almost at the 20-minute mark. So 2b, we've got a parabola. Remember parabolas, guys? Not a parabola, a parallelogram. Parabolas are the big loopy things. Yeah, this is a parallelogram. See, when I'm filming like 20 minutes straight, I can't just cover up all the mistakes I make. It's just like class in real life. So we've got 61 there. We've got 9x minus 2. We've got 124 on this side. We've got 2y over here. And then we've got an angle. This is going to be 12s minus 8. And the degrees really don't matter, but we can put this all as degrees. Just in this instance, it's just kind of, this is more of similarity stuff, so looking at it in degrees isn't necessarily incredibly important, okay? So we need to find the values for s and y, okay? And I can give these labels as well, D, E, G, and F. Okay, so if I need to find s and y, and again, I'm on the very bottom one here, this is 2b. To be or not to be? That is the question. Wow, that looks awful. 2b, can I write? Whatever, we're good. Sorry if you have OCD. Okay, so if I need to find s, then what I'm going to do is, if this is a parallelogram, what that means is that the opposite angles are equal. Okay, so these angles across from each other are equal. So to find s, so to solve s, essentially all I'm doing is 12s minus 8 equals 52. And I'm hoping that at this point, you guys are like really just great with your algebra skills, and you can kind of see this and be like, oh, I sort of know how to solve that. I need to get s by itself, so the first thing I'm going to do is I'm going to go plus 8 on both sides to get rid of this right here. Okay, because I need to isolate this to begin. So I'm going to go plus 8, plus 8. This goes to 0. 52 plus 8 is 60, equals 12s. Okay, and so if it's 12s, I divide both sides by 12. Boom, divide by 12, and that's going to give me s equals 60 divided by 12 is 5. Perfect. Okay, now we're going to do the same exact thing to solve y. Okay, so to solve y. This is a parallelogram, so that means that this long side is going to be equal to this long side. It's all good. This one's pretty easy. 124 equals 2y. Okay, so 124 equals 2y. I want y by itself, so what am I going to do? Caden, who's on his phone, just kidding. I'm going to divide both sides by 2. Divide by 2, divide by 2. 124 divided by 2 is going to be 62. So 62 equals y. And that's how we get our answer there. Let me double check, make sure we got those right. Y equals 62, s equals 5. We're in good shape, okay? And this y looks kind of funny. We'll fix it, but there we go, okay? All right, so I hope that this stuff this is like a good refresher so far. We've got 1 or 2 more to do, just the one more. Okay, so we've got this one with the big, long 2a right here. So 2a, we'll just power through this one real quick. Oh my gosh, it's not focusing at all. Whatever, you guys, at least I hope you have it, and you can kind of see what we're doing here. So I'll draw it up on the board real quick. And who knows, maybe I'll figure out how to like edit these videos. I'm gonna like learn a lot about making videos through this process, you guys. And by the end of the year, if this does end up going that long, I'm just gonna be awesome at making videos. They'll be all edited and awesome. And you won't have to worry about watching me ramble my way through a lecture like this one's going to be. Okay, so, and yeah, essentially this is an entire classwork, how should I say, an entire period worth of work. So what we would normally do, where this would maybe take like 50 minutes, I'm trying to cut it down like in half for you guys. Okay, and the nice thing is this is video format, so you can sort of go through, you can pause, you can go back, and you can post comments. I'm going to answer them as needed. So we've got Q, we've got P, we've got R, and then we've got, this is going back to, I believe it's called the bisector, something like mid-segment bisector theorem. Something like that where, let's see, so bisector here, we kind of do this thing. We've got a bisector like this, and we've got a bisector kind of doing this, okay? And so what we need to do is we need to solve for these variables. So we've got 5r plus 3 here, 5r plus 3. We've got 3p minus 2, 3p minus 2, and we've got 33. And then there's a couple more things down here. We've got 3q, and we've got 63. Okay, so this is actually, this looks like a lot, and it looks like a little messy, but this is really not that bad, you guys. So the first thing we can do, so we need to solve for the variables p, r, and q. So I'm going to go for q first, and the reason why is because this is exactly what we did on the one that I just erased. This is like the mid-segment theorem problem, basically, okay? So because this line, this dotted line is perfectly cutting this whole thing in half, that means that this half equals this half, okay? So 3q equals 63. So to solve q, we're gonna solve q, solve q, 3q equals 63. This one's super easy. It's one step, we divide both sides by 3. And we get q equals 21. Boom, easy. Okay, so now the next one is that to solve for these variables, we're gonna do the same thing for both of them. And what we're gonna do is we have this line right here, pq minus 2, is equal to this, which is 33, which is equal to this, which is 5r plus 3. So just a little tangent for a second. If we had our graphing calculators, now this would be kind of fun, we could actually solve. We could put 3p minus 2 equals 5r plus 3, put it into our graph it, and where they intersect would actually, that would give us our answers for p and q. There's like a couple other things we'd have to do, but that's sort of a little throwback to something we did recently. We're not going to do it that way here though. We're going to use this 33 for both of them. So the first thing I'm going to do if I want to solve for p, so we'll solve p here. And we're going to say, solve p, 3p minus 2 equals 33. And then, first thing we're going to do is we're going to add 2 to both sides, plus 2. Zeros out here, we get 35. So we're going to kind of end up with a fraction for our answer, and that's fine. We can have fractions. So now I've got basically 3p equals 35. So now I divide by 3 on both sides. Divide by 3, which gives me an answer of p equals, and I'm just going to leave it as 35 divided by 3. Okay, 35 over 3. If I wanted to actually do the math there, real quick, power, 35 divided by 3. That just gives me a fraction. That's hilarious. Okay, it would be like a little over 11. I think it would be like 11.66. Someone check me on it. So this would be about 11.66. Actually, I've got the answers right here. I'll check myself on it. 11.66. How about that? It's almost like I'm a math teacher. Crazy. Okay, so we've got one more left. And the last one is going to be to solve for r. We're going to have 5r, so we'll solve r. 5r plus 3, I feel like a pirate, 5r plus 3 equals 33. Okay, we're doing the same thing we did up there. This is like 2 steps essentially. We need to get rid of the 3 first, so it's plus 3. So to get rid of it, I do minus 3 because it's plus 3. We add the opposite, minus 3. 33 minus 3 is 30, so 5r equals 30. And now we divide both sides by 5. That's how we get r by itself, because we read this as 5 times r equals 30. The opposite of times, multiplying is division, so divide by 5. Okay? Divide by 5, and I've got r equals 6. And that's basically it for what I'm doing on Sage Review number 1, you guys. I think we're probably like close to 25 minutes for the video length. And again, if you want to like move around, I'll see if I can maybe edit it a little bit. If not, you've got everything you need in the video to do what's on the left side here. Okay, so let's remember, do what's on the right side on your own, and then just upload it. You can take pictures and email them to me. You can scan it. You can do whatever you got to do to make sure that I can see that you did the work, and you're going to get credit, and we're going to go from there. So thanks for watching, you guys. I look forward to making the next video, and I'll see you next time.